In this video, we're going to talk about functions and decision trees. So you probably recall from basic math class that a function f takes as input something from some set x and outputs something from some range y. So generally you see y equals f of x written like this. And these same kinds of mathematical functions that take something as an input and return a value as an output can also be done in programming languages, and it's one of the most fundamental things. So in general, we can think of this like a vending machine. You're given, or you build this machine, and it takes as input some money, and it'll output a drink. And after you build the machine, you never have to build it again. You can keep using it as many times as you want. So there's some confusion in P2 about people just copying definitions of functions again, so you don't have to do that, and we'll show some examples in this video. So here's some basic functions that you've probably seen before. The first one's an indicator function. So it just tells you yes, which is indicated by a 1, if your input x was equal to this value L. Whatever L is, it could be 3, it could be pi, whatever you want. And otherwise, if they're not equal, it outputs 0. So let's start by looking at some Python code. So the first thing I'm going to do is import everything in the math library. So that's what from math import star means. So once we have done that, we have access to a bunch of cool functions like square roots. So let's just start by making a basic function f of x, and we'll just have it return 3. So that's a whole function definition, and now if we say y equals f of x, y now contains the value of f of x, but we have to specify what x is. So x is just a free variable. It doesn't actually have meaning, so we have to give a specific value as input, so like 4. And then if we output the value of y, which we can just place y here, we can say print y and run that line, then we'll get 3. And we change this to 7, etc., we'll continually get the updated value. So that's just basically how Python functions work. You just say def, the name of the function, its input parameters, which there could be several, and then a colon. And then the return tells you what it's outputting. And you could have as many lines as you want in between. So we could have a sum function that outputs the sum of two things. And again, we should get 7. So everything seems to work fine. So now let's try to implement some of these basic math functions here. So the indicator, let's just try an indicator for 3. So let's call it indicator 3, and it'll just take as input x, and it returns true, which would be 1, exactly when x equals 3. So if we do that, we can again try to see what happens when we run this function on some input like 5. And we forgot the 3, so let's get the names all correct. So it says false, so you can interpret that as a 0. And then if we put 3, we'll get true, which you could interpret as a 1. So that's the indicator function, very basic. Now if we're going a little further on, we can now look at parabolas. So you probably remember what a parabola is. It's just take the input and square it. So we could also call this square. And all it's going to do is square x, which you can do again with the double star. And you can do this with any power, so you can do that with any k here you want. But we'll just do square. So now we can print square of, say, 3, and it should give us 9. So that looks great. And we can continually get more complicated to polynomials, exponentials. So something nice about the math library is exponentials are already defined for us. So if we wanted to do e to the x, we can just return math's version of e to the x, which is exp. So if you didn't import math's, import everything from math, you'd have to type math dot here, but we've already done that, so we don't have to. So then if we do e to the 1, say, we just get out the basic value of e, which is 2.71. So cool, so that's basic ideas of functions. You have some input, and it returns an output. So we can also, as I mentioned, after we build these functions, we can use them in other functions. So if we make some new function, we'll just say it's e square. So we're just gonna square e. So what we'll do is we can return e to the 1, which is the function we just defined with input 1, which will just be e. And then we'll put that as input to the square function. So if we do that, what will happen is we'll get e as the result from e to the 1, and then that becomes the input to square, and then that squares it. So it's very similar to the idea of function composition, which you've probably seen before. So you can do that all the time in Python really simply, and you don't have to copy the code. So you don't have to put exp here or anything like that. You can just use your previously defined functions. So then if we print e squared here of x, notice actually we don't use this input x, so really we could just make it a blank function there without any input. If we call it, we get the correct value, so everything's great. Now we could make this even more complicated. We could also have it multiply by something, so multiply by x, and then now it has an input, which is just going to scale the value from e squared. So those are some basic math functions, pretty easy to implement. Now let's implement something a little harder. So we're going to compute the roots of some sort of quadratic polynomial. So the first thing to note here is a typical quadratic polynomial looks like this, and we don't actually have x because it's itself a function, so we have to represent it somehow. We want to plug a function into another function. So one way we can do this is just using the coefficients of the quadratic. So we just take a, b, and c as input, and then we can use our traditional quadratic formula. So let's just define that. And it'll take as input the coefficients. And we just need to compute the basic quadratic formula to get the two roots. And already we see that there's this plus minus, and we can't do a plus minus in Python. We basically have to pick one of the terms, either the plus or the minus. So to deal with this, we're going to have an additional input I, where I is going to indicate whether we want the plus root or the minus root. So we'll just say if I equals 0, we want the plus one. So if I equals 0, we're going to try to compute this, where we're going to use plus in this plus minus. So if we just compute that formula, and ignore the squared there, that's just a typo. So the numerator is going to be negative b, then plus the square root, which we can just use the square root function because we imported everything from math. And then it's b squared minus 4 times a times c. Then the denominator is going to be just 2 times a. And then all we want to return is the numerator divided by the denominator. And otherwise, if I is not 0, we're going to say that means we want the minus 1. So we can do basically the same code, except now we're going to have a minus. So already you can see conditionals coming in here, where we're going to use the truth value of this statement in order to determine which code we execute. So that completes the whole function, and we can try it out. So let's look at this basic polynomial x minus 1 squared. So this is the same thing as x squared minus 2x plus 1, and the roots of that should be x is plus or minus 1, or just plus 1. It only has a single root, so we don't really care what I is, but we'll just make I equals 0. So let's print quadratic formula of 1 minus 2, 1, and 0, and we get 1, which is correct. And if we instead changed that 0 to 1, we also get 1, and really we can make I anything not 0, and it still works. So that's the quadratic formula, a little more complicated, and that's basically functions. So right here, square root itself is a function, so you can see we did some more function composition here. And we could have even used square of b too if we wanted to. So if we just put square of b here instead, we can run everything again and still get the correct answer. And we didn't have to copy any code. So now we're going to take a little detour from math functions and look at decision trees. So decision trees is an idea from AI where you basically have this tool, the tree, which is giving you ways to predict future events. So you just take your input data and you follow the branches of the tree, and that's going to tell you what our prediction is that we think will be correct. So a simple example of this is you typically want to predict the value of some function that you don't know. So here we actually do know. We're going to take the OR function. We know its values. Here's its truth table. So if x1 is true and x2 is also true, it should be true, and the same for the rest of these based on its values. Here's its output. So we want to make a tree representing this function. So here's one such tree. We take x1 equals 1. This is an if statement basically. So if x1 is equal to 1, then we go down this yes branch and we say, okay, we're predicting the function should be 1. Now here we already know what the function is, so we're not really predicting this is exact, but if we didn't know the function, this would be our prediction value. And then similarly, if x1 is not 1, so it's 0, or false, so true and false are the same as 1 and 0 typically, then we go down the no branch, check if x2 is equal to 1, and if it is, we go to say yes, y is equal to 1, or y is true, or we say no, and y equals to 0. So we have this truth table here and this decision tree, and we want to make a function representing this tree. So we want to represent the prediction. So since we already know what the function is, I mean, we could do this really easily. We could just have a function, we'll call it OR, and it takes in two inputs, x1 and x2, and all it's going to return is x1 or x2. So in Python, OR can be a logical OR or a bitwise OR, but for our purposes, this OR should work just fine. So if we then print OR of 1, 1, we get 1. If we do OR of 0, 1, we still get 1. And if we do 0, 0, according to the truth table, we should get 0, which we do. So that's a really easy way to do this. Just exactly implement the function. But say you didn't know what the function was or the structure, and you just had the decision tree. So in that case, we need to use conditionals. So we say if x1 equals 1, just like what the tree does at the very top at the root. And then if this is true, we know we go to the left branch, which means we return 1, because that's our y value. Otherwise, we go into a second check, which is x2 equals 1. And again, if it is, we return 1. And if it is not, then we know both x2 and x1 are 0, and so we should output a 0. So we return 0. So this is a little more complicated, but this will be the same OR function we just saw a second ago. So if we put in two zeros here, we get 0, and if we put at least 1, 1, we get 1. So that's one basic way to implement this tree. We could have also used else ifs instead. So if we just throw in an elif right here, this will implement the same logic. So make sure your indentation is correct. So the flow of the logic is if x1's 1, we return 1. Otherwise, if x2 is 1, but we know x1's not, we return 1, so that's still correct. And if they're both not 1, we return 0. So this also correctly implements the OR function. And it's slightly simpler than that huge nested if-else from before. So that's basics of decision trees. So we have that tree there, and we're using inputs to predict the output. So we use the data from the tree given, and given new inputs, x1 and x2, we can predict or compute its value using these sequences of if and else. So here's a little more complicated one. This one will work for any f and g function, so let's just pick some f and g function. So let's define f of x1, x2. We can make this as complicated as we want, so let's just return x1 times x2. Now let's define g of x1, x2 just to be a constant. So we're going to return 3. So we call these threshold functions because it says anytime we're bigger than this function, then we're going to say true. So everything above it's true, so we call it a threshold. So now if we want to define our predictions, we can say predictions of x1, x2, and we implement almost the same logic from before. So if x1 is greater than or equal to f of x1, x2, then we're going to return 1. And otherwise, we have a different check, so we'll do an elif again. So if x2 is greater than or equal to g of x1, x2, we're going to return 1. Or actually, we're going to return 0 in that case for this tree. And the last case, we're going to return 1. So this prediction function is exactly encoding the logic in this decision tree. So if you want to turn this into just predicate logic, it's basically the same as this. You're just taking an OR of x1 being at least f of x1, x2, or x2 is strictly less than g of x1, x2. So if either of those is true, then we'll have a 1 there. And if this was a 1 instead and this was a 0, this would be an AND. So that's the basic predictions here. So if we then call the prediction function, we can see what our predictions are for some basic numbers. So 0, 0 is 1, 0, 3 is also 1. So let's try to compute something that will make it 0. So we want x1 to be less than the product of x1 and x2. So if x1 is 1 and x2 is 1/2, then that will be true. And then x2 is 1/2 will not be greater than this though. So that's not going to work. So you can play around with these values and eventually you can come up with one that will give you 0, which will work for 5 and 3. And that's just because 5 is bigger than, or 5 is not bigger than 15, but 3 is bigger than or equal to 3, so we get the 0 there. So that's basically everything you need to know about decision trees. Just look at the tree, read off these if statements basically, turn them into code using if else if, or just if and else if you prefer. And then functions, they're just like mathematical functions you know. You just build a machine basically that takes an input and returns some output. And here's a few examples of that. So hopefully you'll now be ready to tackle functions and decision tree-like problems.